right, so we said that the common ion effect is a way of reducing the solubility of an ionic solid, where if I dissolve the solid in a solution that contains a common ion, the Chatelier's principle takes over and says that if you have extra of something, you should shift away from what was added. In this case, if I had extra silver ion or extra dichromate ion, I would shift away from those ions, and shifting in reverse then favors the original solid. So if I'm favoring the solid, I'm reducing the solubility. I just want to take a moment and give you another example of how to shift the solubility. And so the common ion effect will reduce the solubility, but what if I want to increase the solubility? So let's just take a pause and talk about two ways of increasing the solubility. All right. Let's use this equation as an example. Something like calcium hydroxide. Calcium hydroxide is only slightly soluble. And so if it dissociates, I would form some calcium plus 2, aqueous, and hydroxide minus 1, aqueous. All right, let's use this as our equation. So if that calcium hydroxide is only slightly soluble, what if I want to increase its solubility? Obviously, if I wanted to decrease the solubility, I could say, well, dissolve that calcium hydroxide in a solution of calcium chloride. Add some extra calcium ions. Or maybe a solution of sodium hydroxide. Make one ion a spectator, like chlorine or sodium, and then the other ion would be a common ion. If I have a solution that has calcium ions or has hydroxide ions, that would shift it reverse. But what if I want to shift it forward? What if I want to increase the solubility? Then you have a few options. Option 1. Option 1 would be to form a precipitate. Add something that will form a precipitate with one of your ions produced. So for example, in this case, what if I add that calcium hydroxide, add it to a solution of, how about some sodium carbonate? What if I take that calcium hydroxide and I don't dissolve it in water? What if I dissolve it in a solution of sodium carbonate? Well, sodium is not part of this equation, and sodium can't react with anything. Sodium is aqueous with everything, 100% aqueous with everything. But carbonate is a negative ion, and it could potentially react with something like calcium and form calcium carbonate solid. Well, what if you form a precipitate then? If I form a precipitate with that calcium ion, now that's a way of removing calcium ions. That removes calcium ions. We did this a little bit in the equilibrium unit when we maybe added a solution that had chlorine, and the chlorine reacted with silver ions and formed a precipitate of silver chloride, and it removed the silver ion from the solution. Same gig. That here I could add something that precipitates that calcium. And if I remove calcium, if I do something to remove calcium, Well, then I'm going to shift more forward to replace calcium. Well, in shifting more forward, now you're increasing the solubility of that calcium hydroxide. Ah, okay, that kind of makes sense. It's totally just Le Chatelier. If you remove something, you shift to replace it. Well, here, the way to remove an ion is by forming a precipitate. And now that would increase the solubility of the original solid. Another option, option 2. I'm going to say form water. Here's another option here. We could form water. How do we form water? This is pretty common. An example might be something like the calcium hydroxide is added to an acidic solution. What if they said something like, you're going to add that calcium hydroxide not just to water, but to an acidic solution? But an acid contains hydrogen ions. An acid contains hydrogen. Do you see what would happen here? Obviously, like, hydrogen has no interest in reacting with calcium. They're both positive. But calcium would react with hydroxide and form water. So you'd form HOH, or liquid water. And then that would be a way of removing the hydroxide. And we could form a solid precipitate. Obviously, solids don't dissociate, but neither do liquids. So if I form like liquid water, then that hydroxide is not an ion anymore that's swimming around in the solution. It's kind of like forming a precipitate. It's just not a solid. It would be a pure liquid. So now same gig. If I remove the hydroxide by forming liquid water, now again I want to shift more forward to replace the hydroxide. So it's totally just Le Chatelier, an application of Le Chatelier's principle. But if we're going to talk about reducing the solubility by adding a common ion, then we should also mention that there are ways of increasing the solubility. Besides just like heating the solution, you could also remove one of your ions, commonly done by either forming a precipitate or maybe removing hydroxide by forming water.